thank you to everybody for joining us tonight and taking a couple minutes out of your evening for what will be a great presentation between myself, our panel. We're missing. We're good. Okay, got everybody. But again, thank you for coming. Greatly appreciated. Quick rundown of the agenda and what we'll cover over the next hour or so. I'll do about 15, maybe 20 minutes on 3D laser scanning, reality capture in general, not specific to the panel that we're going to talk about with the Pinnacle Penthouse. We'll just do a kind of a 101. We'll jump into the panel from there, and that's going to be the focus of tonight's presentation. We'll talk about the project in itself, the building, the penthouse. We'll talk about the field work. We'll talk a little bit about the drone imagery that we used, and then we'll leave plenty of time for Q&A, and hopefully you can stick around after for some networking as well. So quick rundown of the agenda. Existing conditions. We have been around for 27 years, and what do we do? In short, we document buildings. We provide accurate as-built drawings to our customers, whether it be architects, owners, developers, engineers, anybody who needs accurate documentation of their building and either doesn't have drawings or might have drawings but doesn't necessarily have a lot of confidence in what's on those drawings. That's where we get involved. And we'll talk about the different deliverables and the different things that we can offer to our clients. So when we talk about the process of 3D laser scanning, and I'm just curious before I go any further, quick show of hands, how many in this room, if this is 101 for you, you have zero experience when it comes to laser scanning technology? Okay, perfect, great. And anyone who would say they're more, just enough to be dangerous? Okay, one brave soul, okay. So we'll talk about, first and foremost, what is reality capture? How do we go about capturing these conditions? And reality capture can be defined as anything other than, we can start with something as basic as a tape measure and a piece of paper, which many of you might be doing. And then as we move forward and we get into using technology to document what exists in the field, we get into what we're going to focus on tonight, which is 3D laser scanning. Okay, so there's a number of different types of scanners that we use to be able to scan a building, be it interior or exterior. And each scanner is chosen based on the project requirements. We have scanners that are what we call terrestrial-based LiDAR, and that's important to understand because the type of scanner that we're using, the type of technology that we're deploying is going to determine the level of accuracy that we're going to provide to our clients when we get to a deliverable and we provide either a CAD drawing or Revit model, whatever that client is looking for. So as you evaluate scanning technology and having conversations, it's so important to understand the differences in the type of scanning that we're using, LiDAR being the most accurate. There are other types of scanners that we use. Photogrammetry is a type of reality capture technology, and that's what supports our drone program. SLAM technology is another type of scanning technology that's portable and handheld. And we even have other types of SLAM technology that are wearable. So in this case, you're looking at a NavViz VLX scanner. That's a scanner that sits on your shoulders, and we're able to walk a space. And we use that when we really want to place a premium on speed. Maybe we're doing a hospital or a healthcare facility, assisted living, want to get in and out as quickly as possible. We can use that type of technology and possibly supplement it with a LiDAR-based technology to make sure we're getting the right level of coverage. And then we'll talk about drone surveys as well towards the end of the presentation. So the scanners that we're using, it's important to understand that they're based on what we call line of sight. Okay, so these scanners are not X-ray. They can't scan through walls or through ceilings to see how the buildings were constructed, but they're taking highly accurate measurements, and they have a very long range. So scanners moved around to different parts of the building to get the coverage that we need. And the simplest way to think about it is if you were standing in a room like this and what you can see with the naked eye from this spot is exactly what the scanner will see. So we move the scanner around to different parts of the building until we get the coverage that we need, whether it be interior or exterior. Now the scanners can scan in pitch black. They don't need ambient light in order to capture the level of, capture the detail that we're looking for. To take photos, they would require ambient lighting, and it's important to understand when we have a conversation with our clients, what are we looking for? Are we interested in photography as well, high definition imagery, as well as capturing the detail to build our drawings? It's important to understand up front so that we understand the type of lighting conditions that we need and what we're looking to accomplish with that particular scan. So we can get into anything like, in this particular case, we're looking at MEP. We can do above ceiling scanning. As long as we have visibility into those elements, we can document it. Another picture of our SLAM technology here, where we're using this to scan a space quickly. And the gentleman that you're looking at there is actually Brian Eli. Brian's our VP of Operations, and Brian's actually a former BIM manager. And the reason I mention that is because it's important to understand that when we put these documents together, a lot of our staff has architectural background, okay? So they understand the language of buildings, so to speak, how they go together, and that's important when we're turning over a deliverable to a client. So, and again, keeping this to 15, 20 minutes so we can focus on the presentation, but that's a quick overview of the way the scanners work, okay? How we deploy them in the field, what we can scan, what we can't scan. So that hopefully gives you an idea of phase one in terms of collecting the data. Once we have the data, what we're left with is what we call a point cloud, and that's exactly how it sounds. It's just a collection of points, millions of points in space. Those points don't know, however, if they're part of a wall or a door or a window or somebody who walked in front of the scanner at that time. We just know that we have an accurate measurement with an accurate XYZ coordinate, and that is what we're using as our guide to go build those drawings or build that Revit model. Quick example of a site scan. What you're looking at there is the point cloud overlaid with the photos, in this case in color. So once we've scanned the building, we have the point cloud, we have to go through a process called registration. That's where we get the data cleaned up. We remove anything like reflected surfaces, anything the scanner captured that we don't want to see. We get that ready to model and bring into Revit or CAD. That's a process called registration, and I'm not going to spend too much time there. That's more behind the scenes. It's an important step. It's something that we do internally, but there is a middle step before we go from scanning to production, and it's important to understand that. There is no magic button, so to speak, that turns a point cloud into a set of drawings. This is still being done one wall, one window, one door at a time. If anyone has questions on when that is coming, I'm sure in the near future, but as of now, not as of yet. So again, this is the registration process where we go through, we clean up the data, and every red dot that you see right there represents a scan location. That's where the scanner was placed at the time of survey in order to get the coverage that we needed. Multiple different file formats, the files that we can provide to clients. Not everyone is using Revit and AutoCAD. Some are using programs like SketchUp, Rhino, Vectorworks, ArchiCAD. So we have the ability to import into different software platforms. So most important step, we're now up to production. Okay, so we've scanned, deployed the scanner in the field, we've captured the data, we've cleaned it up, we're ready to model. What is it that we can offer our clients as a deliverable, and what are our clients asking for? And that really depends on the project and what that particular client needs at that time. But it basically breaks down to 4 or 5 different packages, and it's important to understand where you are in the project life cycle, because not everything has to be done day one. While I'm going to have every measurement that exists in that building when I scan, that doesn't necessarily mean that I have to model everything day one. So we can phase this in terms of the deliverables. I'll have clients who will call me and say, Paul, I'm buying a building. Maybe it's a developer or maybe it's an architect who's just starting a project, and say, I need floor plans. All I'm interested in at this point is basic floor plans, square foot calcs, whatever it might be. 6 months later, I might get a call and say, Paul, that building we asked you to scan, I know I only asked you for floor plans, but we need the RCPs, can you do that? We don't have to go back and rescan. We have that data and we have it forever. So we can always add on to the model later on down the road, depending upon if you're unsure what you might need at the time. Reflected ceiling plans, elevations, sections, roof plans. This is all part of our the different deliverable packages. So you choose your menu, so to speak. Some examples of point cloud, and then modeling, and then overlaid with the color data. Some examples of elevations and how we move from the point cloud all the way up to a 3D BIM model if required. And I'll show you a couple of examples on building information models here. LOD, important, I'll mention that. Generally speaking, our standard offering, we model to about LOD 300. But again, that's up to you. Most of our clients are acceptable with that level of LOD, but if we need to go higher, we can always do that. MEP, we do a lot of MEP modeling, be it above ceiling or below ceiling, and with the integration of our parent company, GPRS, we now have the ability to do extensive MEP modeling. We're doing a lot more of that lately as well, both above and below ceiling. Some examples of historical preservation work. We do quite a bit of work for projects that require LPC approval, and we'll talk a little bit more about that when we get into the drone survey. Deformation mapping, that's another deliverable that we offer our clients. These are topography maps, so to speak, where we can do floor flatness analysis. As long as the floors are clean and broom swept, we have the ability to scan the floor slabs and then produce topography maps showing different tolerances depending upon what the client's looking for. But this is used, we often get requests for lab spaces, places, situations where we're really placing a premium on floor flatness. We can offer this for the slabs as well as the walls. So same concept applies, just on the walls where we can show you where the deformation is taking place. Additional deliverables. So again, as I said, there's two things when we scan a building. We're providing the CAD drawing or the Revit model as a deliverable, but part of our package as well is going to be to provide the scan data as well. Okay, that's what the scanner saw at the time of survey, and this can be very helpful if you don't want to have to keep going back and revisiting a site. Be able to pull this right up from your desktop, walk the site virtually, snap some basic measurements. Obviously, for precise measurements, you're going to want to defer to the drawings, but this can be very helpful. While it looks very much like a Google Street View, this is the point cloud overlaid with the photos. So embedded within these photos is the actual scan data. So this can become very helpful to be able to, like I said, snap some basic measurements, maybe share this with a consultant, a sub who's involved with the project, who's just trying to get a better sense of the space without actually having to be there. And this is available both to house locally on your existing machine, or there's some cloud-based offerings as well to make it easier to share amongst the teams. Area calcs, another deliverable that we do for usually education, be it K through 12 or higher education, but a lot of our clients are asking us for legends based on departments. How do we take that data and allocate it to specific departments, whether or not schools are filing for grant money or want to be able to show specifically by area. This is a deliverable that we do for a lot of our academic clients as well. And finally, last but not least, I want to talk about drone surveys because those were an important part of the Pinnacle Penthouse project. But drone surveys are used for areas which are hard to reach with ground-based terrestrial LiDAR. Either they're not safe, we don't have a clear line of sight, but that's where our drones come in. And it's important to understand, as I mentioned, that drones are using something called photogrammetry. They're not using LiDAR. So the accuracy is going to be different. That's not to say that we can't still produce drawings from that, and we'll talk more about that, but it's important to understand that there is a difference between LiDAR and photogrammetry. So these are some situations where we're using aerial drone imagery. And here's an example of a specific building where you can see each one of these triangles is where we had a photo from a drone taken. So this can be used in a number of different ways, whether we're doing forensic investigation, facade analysis, but this is going to allow you to be able to zoom into specific areas on the building if you're doing restoration work, high definition imagery, and even to the point where we can create a searchable database, if you will, where we can start to tag specific items on the building and have that available if you want to have an accurate database, so to speak, of everything that you're looking for. So number of different ways that we can use drone photography, and we'll talk about how we use that specifically on the Woolworth building. And I think that was exactly 15 minutes. Okay, so with that being said, I am going to save questions for the end. I'm sure you have some, and I gave you the higher level version of a normal presentation, but hopefully that gives you a better idea of how we move from scanning to modeling, the steps that are involved, and the limits we have, what the scanners can do, can't do, and the different deliverables that we can offer. So with that said, I'm going to turn it over to the panel. Jesus, you're going to need to move down because you're in my seat. Thank you. And we're going to dig into what you all came here for, which is the Woolworth building, specifically the Pinnacle Penthouse. Okay, so welcome to the panel. Let's start with some introductions. David, please.
My name's David Hobson. I have an office here in New York.
And David, I apologize. Do we need the microphones? Can everyone hear? Or
okay. And I was actually brought in by Alchemy, the developer for the Pinnacle Penthouse, and actually the whole conversion of the Woolworth building to residential condominiums to study the possibilities of this amazing 5-level residential space up at the summit of the Woolworth. And I have a bit of a presentation we'll get into later where we will walk through the process of working with existing conditions and the really extraordinary utility of a process like that for a building that's so complex, so intricate in its irregular geometry, so full of intricate structural conditions that we wanted to integrate into the design. So I'm here to talk about those things a little bit later on.
That's yours. That's yours.
Why, thank you.
Hey guys, my name is Andy Richard Jalapa, and I was the PM on this project for the product side of things, and I was also the pilot in command, so I had to do a lot with the drone part of this project.
I'm Jesus Bravo. I'm the operations director here at Exquisite Conditions. I oversee operations from scanning to delivery. I worked alongside Holly and David, also Andy Richard on the product side. And I had the fortunate opportunity to be on site to see the scanning. The drone was great, but I'll give it to you. Yeah.
Great. Thanks, guys. So David, the building itself, let's start there. Iconic building that everyone knows, and this is a unusual piece of real estate that does not come along very often. Can you give us a little bit of a background on the space and how this came to be?
I think the project went through several iterations. I think there was a series of people who bought it and contemplated a transformation, but it was an extremely tall, heavy lift for the developer. They had to put in new elevator shafts in a building. The base of the building is commercial offices, so they were just taking the tower portion and converting it to residential while the offices remained active on a National Register of Historic Landmarks property that is visible out the windows from the Landmarks Preservation Commission. So you can imagine the level of scrutiny, and that is, of course, one of the most beloved buildings in New York, really. So the level of scrutiny that was applied to the developer for this process was extraordinary, and the number of challenges involved in doing structural restoration. They put an enormous water tank for the sprinkler system up on the top. They had to put in whole new machine rooms for the elevator, all bringing all the material up through the elevator shaft. There was no exterior hoist. There was no, so it was an extraordinarily complex project for the developer to get to this point.
What was it about this project? I'm assuming that when it comes to as-built, you don't always work with a company like Existing Conditions. What was it about this space that you saw that said, this one I don't want to tackle on my own?
Well, that was crystal clear from the beginning. We had done a similar project that I'll show you shortly across on the other side of City Hall Park a number of years earlier. And these buildings with, you know, that pre-war ornamental penthouse condition where things start to kind of converge and the geometry gets very irregular, and the dimensional control back in 1912 is not what it was today either. So things are shifting off of center, and there's a lot of irregularity that you couldn't possibly document manually. So there was no question whatsoever that we needed the services of a company that could show us where, you know, every one of these intricate structural elements and intricate parts of the building envelope were positioned, and there's simply no way to do it without your help.
Thank you.
So this particular project, in terms of the scope, when you initially contacted Existing Conditions, was initially, if I believe, floor plans, reflected ceiling plans, some MEP, and I don't know, initially was the drone survey initially asked for, or was that something that when we got out there we figured, okay, this might be something that we want to do?
How do you remember it, Jesus?
I remember that it was part of the conversation, and I don't know if we want to jump into the drone survey, the process of what it's been.
We'd love to hear about, because drone surveys don't happen overnight. There's a process involved. So maybe talk to us a little bit about what goes into flying a drone in New York City.
Yeah, there's been a lot
Flying
of
a drone in New York City, like half a block from Ground Zero and half a block from City Hall.
Yeah, it's for us to even take off. There was a lot of red tape. Andy himself was working with the NYPD department, trying to get this permit. You know, getting signatures, letters in place, having the correct information. That was the first step, and I think it was a question to your question, and then once we got approval, we say, hey, there's a green light. And that's when that came at the end, when we had already scanned the property.
We knew we were going to get right to work on the interior scan because there were no complicated approvals issues involved in that.
Yeah.
And we knew that you had to cover all the approvals issues with the NYPD in order to do the exterior scan. And you had to have a decent day for weather and low winds and everything else. But what I recall is you guys established a schedule. It was pretty immediate. It wasn't a long wait, and you delivered right on schedule. And I'm aware of how complicated it is to get NYPD approval, particularly 50 stories up in the air right on top of City Hall. I don't remember hearing any excuses for delays. You guys got it done on schedule, as my memory recalls the whole thing.
Yeah, kudos to Andy, because he went through the communication, because it does require a lot of patience to go back and forth with the NYPD. But yes, I'm still impressed that we were up there and I could see the Freedom Tower so close. There's a lot of red tape around. You can't be so close to Central Park. I don't know if you want to talk about those regulations, but I'm still impressed how close we were able to fly to next to Freedom Tower.
Yeah, I mean, millions of calls were made. Yeah, that's the quickest way to get things done, is what I'm learning. Just calling, making a quick relationship with NYPD. And this project was really significant to us because it was the first project we were tackling on in New York City, flying legally. And that same year of July of 2021, I'm glad that Mayor Adams is a huge nerd for drones. Because of him, we were able to expedite the process of being able to legally fly in New York City. So in July of 2021, they created the NYPD permit department for drones. And that's where the relationship started, asking a million questions. What do you need from us? Important documentation, flight paths. I think the hardest part of everything was trying to get the certificate of insurance for the drone specifically. It's atypical to anything else, and it's so it's a weird request that they ask from us. But you know, we were able to get that permit, and once we got that permit, we were able to confirm with David, hey, like, we're ready to fly, we can do this, let's do this. And
I was generally aware of the intricate bureaucracy that you had to work your way through, and that this was a new set of requirements, relatively new, and yet I was not aware. I was not kept, you know, in some kind of irritating level of detail. You guys took care of it. So.
Yeah, we like to make things easier for our clients. We consider ourselves an extension to all of our clients' teams, and that's our pride and joy. We enjoy to communicate with the client, know exactly their needs, and all right, leave this to us. We're existing conditions. We'll take care of that for you.
Great. So the red tape is behind us. We're ready to scan. Hey, Jesus, maybe take us through a little bit on what we used for this particular project. Now that we have approval, we're on site. I believe it was the Leica RTC 360. Maybe take us through a little bit of the hardware side and how long it took, any of the challenges that we ran into.
Yes. So when, like David said, we have a system, and we've been in the industry at that time for 25 years. So we've been able to fine-tune the process, run into experiences where we know what's needed for the project. And our flagship scanner is the Leica 360. But with this complexity, we were aware that there was going to be some post-scanning. So we wanted to make sure that we had the best data, but also the greatest data. I like to explain scan data as behavior. Scan data, when it runs through this process, it tends to shift sometimes. So we had to bring in the P series, and that basically enabled us to keep the data firm for future visits. And up to this date, we did set internal control on our behalf. So if we were to do any additional scanning at the Woolworth, we would be targeting those control points that we used to tie our data so it can snap back into place. So if we were to continue layering that scan data in Revit with Andy's team, that would snap back in. You would have no issues. Yeah. Yeah. And just to give you an overview of how long this took, it took 1 day to run the RTC, about 6 hours. I believe it's 5 stories of space. We went to the.
How you count.
Yep.
You say 7 if you count mezzanines and things.
Yeah, and you'll see through the images that there's a spiral stairs. You can get lost once you get to the mechanical room space. There's that top terrace that's very iconic. We did experience that there was some blind line of sight. There was some missing data. And that's very typical because the scanners don't penetrate to surfaces. And they won't scan what's below. The only blind spot there is below the tripod. So that's when the drone came in as well, which is kind of complemented that information. And the lower part of the exteriors, when we came out to the terrace, that fell in those lower exterior points. But it's definitely, I'm still shocked. I've been with existing conditions for 8 years, and I'm still shocked to this day at the amount of data we get, the level of detail also for this historical building. Yeah.
And the utility of being able to come in after you've started construction and do supplemental scans and have them, locked precisely to the same control points is incredibly useful because, especially in a project like that, it's almost impossible to map out exactly how the MEP would move through those sloping, ceiling volumes, but to be able to kind of rescan and confirm precisely what the evolving site conditions are is another extremely useful part of your services.
And you want to talk a little bit David, I know we want to give you some time to show some of what you've done with the data on your side, but maybe just a quick overview of the drone flight, any challenges there, or we talked a little bit earlier about drone being photogrammetry versus LiDAR scanning, and how we worked with that data to give David ultimately what he needed in terms of the deliverable.
Yeah, with drones, there's always going to be something going on. You know, we were able to get that permit from the NYPD, but then, all right, it's time to fly, right? We're on site. There's a lot of obstacles that we kind of need to face before taking off and just flying the drone. I know it sounds simple. Let's just open the drone, turn it on, fly. But we need to figure some other things like wind speeds, weather, birds. And I say this with so much enthusiasm because I was actually at a site today, and there were a lot of birds in the way. So it's just kind of extending the project. But thankfully for this project, at such high altitude, I think it was great because I didn't have that bird situation happen. The winds were beautiful. The sun was out. It was a perfect day to fly. And we do backup dates, and the NYPD permit does allow you to have up to 5 dates. Sometimes we need all 5 days. Sometimes we just need one, but we fill all days just to make sure that we have at least one good solid day to fly.
Great, thanks, Andy. So we've spent some time talking about the upfront logistics, what goes into the field work, but I think we'd love to see what came out. So David, I'm gonna turn it over to you, I think, at this point.
This is my first time seeing this, so.
Hey, can you switch the screen, please, to the computer? Awesome, thanks.
So as I mentioned, I was approached by Alchemy, the developer for the Pinnacle, because they were familiar with the project we'd done under the little red triangle there on the site, which is a penthouse on top of a building that was considered a skyscraper when it was first built. It was one of the tallest buildings in New York. It's like 25 stories tall, built in 1893, so 20 years before the Woolworth. There was this series of early skyscrapers called Newspaper Row sitting opposite City Hall Park at the foot of the Brooklyn Bridge. And unfortunately, the New York World and the New York Tribune were demolished. The New York Times building still remains, and behind that was something called the American Tract Society building, which was a publisher of religious tracts, which was as large a publisher as the New York Times. And if you look at the corners, you'll see that there were these angel caryatids wrapped around the corners of the building as a sort of emblem of its function as a religious publisher. This project is somewhat similar to the Woolworth in that it has this incredibly ornate exterior shell, but no surviving interior detail other than the original arched windows, the kind of extraordinary pyramidal interior volume, and the riveted steel structure, in this case from 1893, one of the oldest surviving steel frame buildings in New York. And we had worked to create these, this was a 5-story tall space, and we kind of exposed elements of the steel structure as a sort of historical artifact that happens to also support the building all the way through. The living room was 4 stories tall. The owner wanted to have a sort of belaying reel and a series of climbing holds installed on the central column that climbed up through the middle of it. So it was an interesting exercise, I suppose you could say, for considering work on the building that sits right across City Hall Park, which truly is the most audacious, ambitious work of architecture. The fact that it towered above the neighbors. Here is a guy putting on the structural steel. You can see the rest of it. You can see right next to it, that's the top of the building where we did the other penthouse. The fact that in 1912, they decided to go 50 stories, 60 stories above the street, far higher than any building had ever been built, that they had the audacity to engineer the foundations, engineer the steel structure, figure out how to get materials up there, build this whole thing, before the First World War. It's absolutely incredible. And of course, I was fascinated to see all the early images of the 7 or 8 story interior of the Pinnacle, and to get inside and see the steel structure that had been supplemented somewhat by the engineers who had needed to restructure portions of the building. Actually, the only thing that they needed to supplement was the structural steel at the summit. This was viewed as a bit inadequate for contemporary structural engineering, although the rest of the building was perfectly adequate. So we were interested in this notion of sort of framing elements of the steel structure as as this kind of extraordinary physical artifact in the technological and commercial and economic history of New York City. When we took over, the project was at this sort of white box stage. But in order to get the scan data, we felt it was important to strip away the sheetrock finishes that have been installed for the sales process, so that we could be looking at the face of the original terracotta that could not be moved, as the exterior envelope of the building. So the whole thing was stripped of its superficial sheetrock finishes, and then existing conditions came in, and what you're looking at here is the point cloud documentation that they delivered. You can sort of get a sense as it moves, in the foreground, that all those are little points describing the incredibly intricate physical structure and all the layers of infrastructure that have been added to it. Obviously, we need some of this material to be stripped away. We wanted to get back to the skeleton, and of course, they deliver whatever specification you have for, some people need every duct and every sprinkler pipe. We wanted to have just the structural and the envelope and the windows and the floor slabs in our data. So that's what they delivered to us. They delivered a Revit model that accurately located all of the structural elements, and we got to work converting that into a three-dimensional architectural design using their this one's not working. We've got there we go, sorry. So it was this process of being able to work with very accurate structural description of the building on a very, very intricate and complex three-dimensional envelope, with the sense that the kind of precision we wanted to achieve in the actual finished product could actually be realized. I'm hoping I can get this video to play, but it's not working. The opportunity to work in a building that is on the National Register of Historic Places, and that has this extraordinary structural envelope, structural skeleton, and these amazing steel connections that are themselves pieces of history, was a really amazing opportunity. And as we worked on it, we became more the purchaser got to be very interested in the prospect of restoring some aspects of the exterior, which of course is a hugely expensive and difficult operation. So we did a preliminary design study of what would be involved in restoring particularly the top of these four corner terrelles, which are really remarkable works of architecture in their original configuration, but they'd been stripped and clad in aluminum in the 70s before the building was landmarked. Originally they were open. You could see right through them. They had this, diaphanous transparency. They have these astonishing Gothic ornament that, of course, is completely invisible from the street. You really can't see it, but from inside the Pinnacle apartment, they're actually very disappointing in their current configuration. And we wanted to look at what would be involved in bringing them back closer to their original configuration. And so here you see, this is a video too, if I can get it to go. You can see what was done in the 70s if you look at those corner terrelles now. Just a cartoon version of the original Cass Gilbert design. It's just it's a terrible disappointment when you see them up close. The one on the far side was the original chimney flue for the boiler that heated the building, and so this elaborate Gothic finial was actually just a big chimney. But so much of this was invisible. There was simply no way to see the exterior of these terrelles or to see the lantern at the top, for example. You can't stand on that terrace at the top and see the upper tiers of the lantern. And it wasn't until we got all these fantastic images and drone shots that we actually had a clear picture of how many pieces of the original historic ornament were missing, what the condition and what the issues involved in an attempt to restore that would be. So it's fantastic to be able to examine the building that is completely inaccessible through the services of existing conditions. And the other totally amazing thing is this photogrammetry, which, as Paul explained, is not as accurate as the LiDAR scan on the interior, but the fact is you take hundreds of photographs and you've recorded the precise position in space of each of those cameras so that the perspective can be merged into a single image and model. It's a 3D, it's a manipulatable, model that is, again, not as accurate as the LiDAR scan, but it's an incredibly useful three-dimensional document that combines, they did LiDAR scans from the terraces on the 49th floor and from the top, but you can't see everything. The scanning devices are line of sight, as they've said, so you can't cover everything. But the combination of exterior LiDAR and exterior photogrammetry meant that we could develop, a very accurate. There was a lot of manual work to do to get all of the intricate detail. But you can see a little 3D printed model sitting on the table there that was developed directly from our Rhino model, which came directly from all the data that was provided to us by existing conditions. So I'm ending just with this this kind of montage of the point cloud. You can move through this point cloud as this amazing diaphanous sort of scrim of points, and it's miraculous, frankly, that you can work through the space, document all these points, convert it to accurate three-dimensional model. We sort of just rediscovered some of this material as we were invited a couple of days ago to participate in this discussion, and it'll be fun to get back into it in the coming days, because the richness as an architect, looking at the ability to, you know, to capture a three-dimensional envelope of space and the process through which it's done with the point cloud is really an extraordinary thing. So I wanted to give you a little glimpse of the use that we've made of existing conditions. Superb technology.
Thank you, David. Thank you. So I'd love to, at this point, open it up for questions. I'm sure there's got to be some. So do we have a mic that we can pass around, or maybe just speak loudly?
Where do you see this going in terms of miniaturization? So, for example, on an Apple iPhone, it does have LiDAR, but on a Samsung Galaxy, it doesn't. And yes, right now you have to use these tripods, but do you see the optics improving, especially since what you started with 5 years ago, 10 years ago? Where do you foresee it going in the future?
It's a great question in terms of the size of the scanning technology, and ultimately comes down to, as you said, the accuracy and what we can offer in terms of construction grade drawings versus accuracy that's going to be used to support more just imagery. And to be completely straightforward, I'm not sure where it's headed yet, but as I always tell clients, for the first time, as you're shopping solutions and as you're evaluating different technologies, I think that's really the most important thing to ask yourself is, what are we going to do with this data? Where is this data? Is it going to be used to support work like David's just shown you, or is it going to be used more for imagery, more for showing an example? What's the accuracy? What are the tolerances that you really need? That's the most important thing to keep in mind, and that's why the difference between, you know, an iPhone-based LiDAR scanner and a terrestrial-based LiDAR scanner is going to be completely different. But technology isn't stopping, so I'm sure we are going to be moving in that direction. Just a question of when. Sure.
Had the developer not been interested in restoring some of those exterior elements of the spire and the top of the building, would the drone scan have been useful at all? Like, would you guys have still moved forward with that?
It's a good question. I think it's useful just in terms of maintenance. I mean, the fact that you cannot inspect the exterior of the building without, you know, without availing yourself of that technology in itself is a reason why it's worth the investment.
Yeah, and that's really where the conversation starts to shift to more of a facilities management discussion, where it's not just about the work that we're doing now to support renovation, but the data that we have forever. How can we repurpose that data for the owner, who's going to have to be responsible for facilities for that building for years to come, and how do we make that available to them? So it's not always just about the project itself, but about the building and the years to come. Sorry, go ahead.
I have a few technical questions. I'm curious if you guys could talk more about the control points and how that worked into the process of scanning. That's number one. And second, I was wondering if you guys if you all registered the drone scan to the LiDAR scan.
Andy or Jesus, I'm going to let you take the survey control question first.
Yeah, I'll let you take the drone one because that's still under development. But
He takes the easy one.
so there's the land survey control, and we've received a lot of CAD files of existing buildings where there has been a site survey or a land survey, and many times they don't have control, and you know, you'll get like axes of elevation marks, but they don't have an X, Y, and Z. So those type of things, they do have to be requested to the surveyor. They will mark something physical on site, either it's a screw or maybe the score X, and that's where we place our target on top of that. That's how we married the existing site and bring it over to the digital world. And for this purpose, there was no land survey control, so we had to establish our control physically on site. That way we can rely, like I mentioned, if we go back on site, we know that we can rely on certain points that are existing on site. And in this internal control exercise, we chose the mechanical rooms, which most likely they won't be touched, hopefully, fingers crossed. And well, there was a couple of mechanical rooms throughout the level, so that's where we have our control. I'm not sure if that answered your question.
They're local control points. They don't tie into any existing land surveyors' drawings. So we can essentially place them wherever we want to. In this case, Jesus mentioned we place them in mechanical rooms. We have to be really meticulous on where we place them because these, they're paper targets. Have you ever seen a black and white square? I've seen them a lot in the MTAs. Essentially, we place them all over, and we pray that no one touches them or moves them, which can happen. So we do have a backup plan for that, and that's just placing a couple extras just to be on the safe side. But it's just local control. And just to kind of follow up with your question, I feel like it might come up. We can tie the point cloud data into a land surveyor's control points, and we've done it recently, and we always do it as well. But this only is needed mainly in big buildings, essentially buildings where we know that we are going to have to return and add additional information. So yeah, I hope that answered your question.
Yes. Yeah, good question. Everything that we're contracted to scan and deliver is going to be delivered to our end client, and it's theirs and theirs forever. It's their intellectual property. They own it. There are services out there, Matterport, for example, where you're going to have to pay an annual subscription fee for them to hold your data, and should you stop paying that fee, you lose it. So we're very particular in the fact that whatever we turn over to David, that's David's, and it's his. It's his property. Underwater LiDAR. That is not a service we were offering at the moment. We do offer leak detection and video pipe inspection. If you're interested in that, we can have that conversation. But no, we're still working on underwater LiDAR.
On a question on the technical side, besides the scanners not being waterproof, the scanners are sensitive to reflective surfaces. This includes water, mirrors, windows. So there is a cleanup process that our team does to maintain the data to have the best results. So in this case, water would affect the scan data.
And that's the registration process we go through as that middle step. Yes. Drone deploy?
We used a couple, but our go-to is drone deploy. It's just because it's easier to store the data and transfer it to David. But we also use the reality capture.
Oh, multiple. Oh, sorry, I'm going to start closest. Go ahead.
Yeah, just a kind of reference to your presentation about getting permission from the city. I got the sense this was treated as sort of an extraordinary gesture on their part to let you do this. Do you think we're getting anywhere closer to some kind of template application for this kind of flyby in Manhattan, or is it still very much a, you need the mayor's signature kind of thing?
No, now it's widely accessible to anyone with a commercial Part 107 drone license. Yeah, I mean, it's still complex. There's a lot of things you kind of need to sign on, and the city, they want to know if they can trust who's going to fly there, and they want to know that there's a backup system just in case anything happens. And you know, it's important. Airspace is super important nowadays, especially in New York City. Yeah, it's widely accessible now. It's not the easiest permit to apply even till now. Yeah, I mean, it was a learning curve, and yeah, I'm just glad we were able to get through it. And now every time we need to fly the drone, it's pretty simple for me. It still takes me about 4 hours to apply for a permit, but it's easier for me because I know what entails into it. It's complex is the answer.
Thanks, Andy. Yes, in the back.
Do you add any other components to the scanning, like thermal scanning or air leakage, things like that, while you're surveying the building envelope?
Have we done thermal?
We did not do thermal for this project.
I know not
but,
for this
but
one.
we do offer thermal imaging with the drones that we have. So if that's something that was part of scope, we would have certainly captured it. For this specific scope, it wasn't, so it was just imagery. Yep.
But just for the drone, not for the LiDAR-based scanning.
Right, it's mainly for the drones. LiDAR, they just, so the scanners that we use, the terrestrial scanners, they just capture essentially just surfaces. So it's the line of sight to it. Doesn't go through any surface. It just creates points and millions of points with the correct X, Y, and Z coordinates.
Would your thermal scans overlay your 3D model? So like if you're looking at it, you can see where the thermal losses are on the envelope?
That's a good question. We'll get back to you on that, but I can, that's a good question. Yeah, we can essentially stitch and create a photogrammetry model from thermal images. So I can see that being super useful. So yeah, we'll definitely take a look into it. Thanks.
Yes.
What's the design process after you get something that's so technical, such a clear scan? Like, how do you get creative with the architect afterwards?
From an architectural standpoint, or sure, David, I'll let you take that.
You know, they existing conditions does the process of converting a point cloud into a Revit or Rhino model. So basically, they delivered to you an accurate, scalable, manipulatable digital model of the project, of the existing conditions. So it's immediately accessible and is just as easy to move and manipulate and design within as something you would have produced in your own office.
I'd like to piggyback on and complement what you mentioned. We always tell our clients that we are an extension of their team. And what this means is that, you know, we want to do what we do best and not make the architect do double the work. And many times I've worked under our architect. Me and Andy have an architecture degree, and you know, who's going on site measuring? Maybe an intern, maybe someone that it's the beginner level. They might forget something, and we've seen it. We experienced it in the past firms, and we want to make the model the best we can, so you can take it on and not duplicate the work. Yeah.
Yes. Sorry, in the back, and then I promise we'll get right up front.
How does the cost of this service compare to an equal pen and paper survey of existing conditions, especially for like a less architecturally significant space, like an academic building? And are there significant economies of scale when you're surveying larger spaces as opposed to small?
Sure. Yeah, there's a couple of things that go into how we price projects and how we come up with a deliverable. And there's really two parts to the process. The first one being the field work. Okay, so to your point about economies of scale, if I'm scanning a 3,000 square foot home versus a 4 million square foot college campus like Williams, which we just finished up last year, obviously if we're scanning 75 buildings, 4 million square feet, economies of scale are going to apply in terms of our daily rate for field work when compared to a smaller project. So on the field work side, yes, certainly economies of scale. And the second part to this is really the modeling scope. And obviously, if we're doing floor plans only, it's going to be priced very differently than if we're doing floor plans, RCPs, interior and exterior elevations, above ceiling MEP scanning. All of that gets rolled into the modeling effort in terms of how we price. So yes.
But it's a completely different end product as well. I mean, the fact that you're delivering, you know, precise, accurate scaled plans, sections, reflected ceiling plans, and a three-dimensional computer model at a level of precision that you couldn't hope to get manually is like it's not just the measured survey. It's like the whole suite of existing conditions, design documents that allow you to start with confidence and not think that someone along the way made a mistake when they were manually measuring something. I would encourage anyone to get a proposal from them, because in my experience, their proposals are quick. They're surprisingly cost-effective when you compare it to the laborious process of measuring something and then developing your own CAD plans and then developing your own three-dimensional model. It's a great value, frankly, in my view.
Thank you, David. It means a lot coming from you. Appreciate that.
Yeah, no, and correct me if I'm wrong, but I think we used your template too, right? Or do you guys send us a template?
Yes, we did. Right, we gave you a BIM template that you guys worked inside of. Yes.
That's an excellent point. If you have a Revit template or layers or standards specific templates that you want us to use, absolutely we can use that. As Jesus said, we want to make sure that you're going to hit the ground with as little rework as possible. When that drawing comes over to you or that model comes to you, you're off and running. You know exactly what you're getting. So, go ahead.
When you move that scanner around to the next point, how does the scanner record the relative location from this one to this one?
There's it's a two-part answer, but the first one is the scanner itself has sensors on each corner. So once the first scan is complete and we move it around, it detects the surface and it allows us to know where the scanner is moving at the time of site. And that's only just to kind of, we call it pre-registration, which is a really helpful tool. We've used many scanners. We have a lot of scanners. We encourage our teammates and our team members to look for the top of the line tools, what can help the client get what they need in terms of accuracy, because that's what we're looking for. We want to make it the most accurate model for our clients. And so with that second answer is registration. So when we're on site, there's pre-registration, and then we have our internal registration team clean up that information, and they use what is called cloud to cloud. And that essentially ties the first scan to the second scan using existing scan data. So it combines the point clouds by detecting the overlapping of point clouds. Keep in mind that the scanners, even though they take about 30 seconds to create a very basic scan, it captures millions and millions of points. So it may even capture things that we aren't really looking for. Maybe Dave just needed floor plans, but at the end of the day, it's capturing so much information that cloud-to-cloud registration just works perfect.
Yes.
Another question. How accurate were you all able to guarantee for the model to be? And also, how long did it take from the scan to go to the model?
In terms of accuracy, there's a number of things that can affect accuracy in a LiDAR-based scanner. Wind, vibration. So we try to stay away from specific numbers, but I would say these are construction-grade drawings. I would say if I had to put a number on this, approximately 1/4 of an inch in accuracy, as opposed to something like we said, an iPhone-based LiDAR scanner, which you could be dealing with, 8-inch tolerances, which not going to serve you well. So that would be my answer in terms of the accuracy. And I'm sorry, the second part of your question was delivery time? We had some phases in here, so I don't know. The initial modeling, normally we can deliver drawings from the time a survey is complete. For this building, it was about 10,000 square feet of space, 12,000, somewhere in that range.
Right.
Generally speaking, from the time that we're done with scanning, probably 2 days for registration, and then I'd say probably another 10 days after that, 10 to 12 days. I think David had his model in hand,
Yeah,
somewhere in
sounds
that
about
time.
right.
Yeah, I think it was about 10 days. But the 10 days start right after we complete the registration. And that's super important because that's super important to note, mainly because every project is different in terms of size. The bigger the building is, the longer our registration team needs to process all that data accurately. So it all depends once we finish, our registration team finishes exporting that information we need.
Yeah, and that's important to understand is that when we scope a project and we outline a schedule for our clients, the type of building that we're scanning is going to determine the amount of scan time. So for a normal building, we can usually, and normal is subjective, we can usually scan about 20, 25,000 square feet per day, somewhere in that range, for maybe an office building, a hospital, a school, somewhere in that range. If we're getting into warehouses, industrial buildings that are wide open, very few walls, we might be able to do 100,000 square feet per day. So the type of building is going to determine the scan time, and also the color versus the grayscale scanning. As I mentioned, our scanning by default is grayscale, and it's no less dimensionally accurate than color. Some of our clients are just fine with that. Others, for a building like this, where we're really placing, a premium on a historical space, we want to get that in color so that you really understand what you're working with. We can probably do about 10,000 square feet per day. So it does take longer to scan in color. The first pass that the scanner does is collecting the data. The second pass it does is taking that high definition imagery and then overlaying the color to colorize the point cloud. So it does take longer. So all of those things get factored in.
And we do offer an expedited modeling time, but at the end of the day, that also starts from the day we finish registrating the data.
Question for David. I'm curious if there were any architectural design choices that you were presented with that you wanted to talk about.
Architectural design choices that I was presented with by the client group or the developer, or?
Or just using this property, like you had mentioned, exposing with a structure.
Right.
And also like constraint, yeah.
Well, a real preoccupation of ours is, a very rigorous modeling of the sort of figure of interior space. And in this case, opening up apertures, the oblique views inside this property, because it's literally 100 feet tall from the top to the bottom, and you can channel vistas through it. It moves in all these intricate ways because you're moving up on staircases, and the whole property is revolving around you, and out the windows, the whole city is revolving around you. One of the extraordinary things about this property is when you get up into the Pinnacle, you are in a single space that has 360 degrees of panorama. There's no elevator or stair core that goes through the middle of it. You couldn't build this today because you're required to create elevator and stair access to every level. So when you're moving through this, the Midtown skyline, the downtown skyline, New Jersey, the Brooklyn Bridge, they're all sort of orbiting through the windows as you move. So we were very focused on this immersive, very rich perspectival experience of movement through the space, and really sort of choreographing that with the staircases and with the with kind of oblique views passing, between levels where you almost lose, a sense of orientation because you're just not accustomed to seeing an oblique view down through the floor that goes, 2 stories down and out a window or something. Like there's this opportunity for a rich, immersive, almost disorienting spatial experience. It's something that happened in the penthouse we did on the other side of City Hall Park, where once you've kind of explored all these levels, and we framed important landmarks in visual corridors that kind of ascend or descend through the building in a whole series of ways. So you're sort of seeing the kind of, it's like a search engine for monuments of New York City in a weird way, and they're happening at different scales. So the design direction we were after really was about a completely unprecedented set of opportunities in this building, because it's such an extraordinary structure, because it has such an amazing history, because it has witnessed the transformation of the island of Manhattan, as the whole city has grown up around it. It just is a completely unsurpassable design exercise in many respects.
Why does the color change in the scan? Is it thermal? Why is there a color change?
Within the model, within the point cloud, once it's registered, we're able to manipulate it in many ways. Changing the color is one of them. In that image, the previous image, I'm not sure if we can go back, Paul, but there were, I think, 3 or 4 colors. And each color represents, it's more for us to view it a little bit more easier. If it was all black and white or in color, the colors might have been a little too faded for you to kind of distinguish things. So that image with the colors, it basically, we changed the settings. So any point clouds facing the X direction is one color, the Y direction one color, the Z direction one color. And that way, when we're modeling the building, we can kind of distinguish these surfaces.
Thanks, Andy.
You're talking about the data being behavioral and specific type of scan. Does the building shift and then when you scan it again? You're talking about like things snapping to when you're scanning again. I was just wondering what you're talking about, how that.
Yeah, so the scan, one scan to itself, it's accurate. Once and that goes along with the exercise that Andy was explaining, how you move on to the next position. And the accuracy depends on how much overlapping data there is. And there is times where you go through a doorway, there is a limited amount of data. And you can scan this building 10 times and maybe you'll get 10 different results, just because data is basically pulling each other and stitching each other from all different directions. So what the internal control does is, you can imagine a big tent, and the control is basically anchors, keeping the data in place. Yeah.
Any other questions?
So right now, do you involve any service? You are doing also the GPR scan for the, if it is a concrete frame structure, then about the 4 slab, you scan the rebar, or the masonry wall or the exterior wall, then you also scan the rebar, the beam, so that you can do structural modification, that you know what to coordinate. Do you have that service?
Yeah, with the integration of GPRS, who's now Existing Conditions parent company, we're offering not only above grade scanning like we've been focusing on tonight, but ground penetrating radar as well, where we can scan through concrete slabs, identifying things like rebar, underground utilities, things that we can't see with a terrestrial-based scanner. Completely different division of our business, but yes, ground penetrating radar is now a service that we offer all under one roof. Yes. Hi.
And this is a comment, not a question. Sort of a comment, question, answer. Somebody asked a question earlier about the difference between working in an architect doing medical drawings and existing conditions. We've been doing historic structures reports with Yale University for about 15 years. The first one we done with a real architect, real measure drawings. Then we discovered existing conditions. And I want to say thank you. There's no comparison between speed, efficiency, cost effectiveness, accuracy, and just an incredibly professional, efficient team. So thank you. Can't wait to
Thank you. Really
Thank you.
appreciate that.
Thank you.
Means a lot. Thank you. Any other questions? Come right back to you. Go.
I don't know if this is question or statement, but I can see opportunity to
can't offer from abroad. There are so many beautiful, gorgeous architecture, which I'm assuming that their documentation is lost or not complete.
Yeah, and at some point in time, that building, whether it be the owner or an architect who's involved with the project, it's not a question of when or if they're going to need accurate documentation. It's just when. So in order to preserve those details, we're with you. We're on board. So,
I mean, historic preservation. We've done previously some work on that before. We've worked on structures where they're still whole, and unfortunately, we've also worked on structures that were burnt down, and it's unfortunate that they hired us at that time. But yeah, I mean, essentially everything we're capturing is part of preserving the history, essentially, just because we're already capturing the existing conditions of those buildings. So it's there. If the architect's gonna make a change, we still have that old database of what was there at the time of survey.
yes.
So back to the questions, whether you're hired by the owner to do the survey, or you're hired by the architects or the design team to do the survey. For example, if you hire civils to do the survey, the site survey, right? They stamp the joint, so that the official, the liabilities on the accuracy on the joints. But once you do the 3D model, if I'm using it for structural renovation purposes, right? So I don't think any structural engineer will rely on a model. All of them probably will be still 2D joints that you sign and seal. So the question is, if you do the survey of those information, that you do the GPR scan or the location of the rebar on the joint, will you stamp a joint that's the as-built as accurate as you can, from the survey that you did? You understand what I'm saying?
I do, and we will not stamp certified drawings. We're not licensed architects or engineers. We would be passing that data along, as David said, to the architect. Here's an accurate set of as-built drawings that we were contracted to provide. And then David, if he had to stamp certify that, would take it from there. We're not going to be in a position to be able to apply a stamp certification to that drawing.
And that's why when we deliver the model, any 3D model, we typically work in Revit, by the way, but every time we deliver a model, we include that point cloud embedded within the model for the client to verify any measurements that may be needed to verify.
One last
Yeah.
question. Yeah. One last question. Sure. When you're doing the drawing or a surveyor, would you be able to have a GPS, the set point, instead of you have to find a marker somewhere in the building? Why cannot be a GPS that you can really have the XYZ super accurate?
Yeah, I mean, we do use that technology is embedded within our drones. There's something that we've been using called RTK that connects to the New York State local system. But yeah, we do use it. For this project, we did not initially. So yeah, but we use it. Yes.
Yeah.
This is a drone permit question. What would you say is a typical turnaround time from your initial contact with the NYPD until you're on the ground and birds are in the sky?
It all depends. It depends on when you're planning to fly, when you have accessibility to fly. There's a lot of requirements to get that drone permit, but once you have that drone permit, those dates that you're set, those 5 limited days per permit that you do, you're set to fly those days.
Yeah, and the process is 30 days prior to your flight date. So you file 30 days prior, and that day could be a hit or miss, right? Because you're dealing with weather. We're also dealing with the flight traffic. If the president's coming to the town and we file 30 days prior, we won't know that the president's in town. And we all know that's for security reasons. So we could get a cancellation a week before we have the date set.
Wait, so right now, are you saying that the quickest turnaround would be 30 days?
Just about.
Yes and no. It depends on how busy they are. With existing conditions and our relationship with NYPD, we can expedite that pretty quickly, up to 14 days. So, yeah.
Anybody else? Well, I want to thank everybody again for coming out. I hope this was helpful.
Thank you.
Really enjoyed having you.
Thank you.